So today we are going to discuss on part 7.2 abstract classes, interfaces and casting. So an abstract class is a class declared with the abstract keyword. So it represents an incomplete type, a class that defines structure and some behavior but cannot be instantiated directly. And abstract classes are quite flexible. They can have constructors which are called by subclasses using super. They can also contain instance variables to store state. So in addition, abstract classes may include fully implemented methods known as concrete methods, which child classes automatically inherit. They can also declare abstract methods, which are methods without a body. These methods define behavior that subclasses must implement. The key restriction is that an abstract class cannot be instantiated. So if you see the code, right, we have abstract class animal, string name int80, and animal string name, that's the constructor. And then we have a method void breadth, and then we have abstract void speak. So let's go through each member. So instance variable name and age are regular instance fields, okay? And abstract classes can hold state just like any other class. So this is a key difference from interfaces which cannot hold instance state. Constructor animal has a constructor that takes a name. Abstract classes can have constructors, so they cannot be called directly with new, but child classes can call them through super. The constructor still runs with a child object. The constructor still runs when a child object is created. And concrete method, breadth has a full implementation. Abstract classes can have fully working methods that child classes inherit and use immediately without overriding. Abstract method, speak has no body, just a semicolon, right? So any class that extends animal and is itself concrete, not abstract, must provide an implementation for speak. The abstract keyword on the method is the contract. Subclasses must fill it in, okay? And animal A is equal to new animal rex, right? So this will lead to compile error. Abstract classes cannot be instantiated. The compiler, it will reject new animal immediately. And abstract class is by definition incomplete. We have to understand that. And speak has no body. Creating an animal object directly would mean that you have an object that cannot respond to speak. Java prevents this at compile time and can use as a reference type. So animal A is equal to new docrex. You cannot create an animal object, but you can absolutely declare a variable of type animal. The actual object must be a concrete subclass, here dog, right? So which extends animal and implements speak. So this is polymorphism and the reference type is animal, but the actual object is dog. Also, if you see a abstract class pet extends animal, right? So an abstract class can extend other abstract class without implementing its abstract methods. Pet extends animal but does not provide a body for speak. So that is fine because pet is also abstract, so it passes the obligation down the chain. The first concrete non-abstract class in the hierarchy is the one that must implement speak. The complete picture of what abstract classes can and cannot do is it can have constructors, it can have instance variables, concrete methods, abstract methods, but what it cannot do is that be instantiated directly with new, can be used as a reference type pointing to a concrete child object. We have to remember that. So implicit modifiers and rules. So an interface in Java defines a contract. So a set of methods that any implementation class agrees to provide. Before Java 8, interfaces were limited to constant variables and abstract method declarations. Any variable declared in an interface is implicitly public, static, and final. These modifiers do not need to be written explicitly because the compiler automatically adds them. As a result, variables in an interface are constants and cannot be modified. Similarly, methods declared in an interface are implicitly public and abstract. Even if these modifiers are not written, they are assumed by the compiler. Because of this rule, when a class implements an interface method, it must declare that method as public. You cannot reduce the visibility of a method when implementing it. Starting with Java 8, interfaces can also include default methods. So we have to understand that a default method has a complete implementation and is marked with the default keyword. This feature allows interfaces to be extended with new methods without breaking the existing implementations. Interfaces can also contain static methods and these methods are not inherited by implementing classes. Okay, so instead they must be called directly through the interface name rather than through a class that implements the interface. So let's come to the code, right? And we see int max altitude is equal to 10,000. So every variable declared in an interface is automatically public, static, and final, whether you write those modifiers or not, and the compiler will add them silently. Public means it is accessible everywhere, static means belongs to the interface itself, not any implementing object, and final means the value can never be changed. These are constants, not instance variables. You cannot modify max altitude, max underscore altitude anywhere. It is logged at 10,000 forever. This is why interfaces cannot hold instant state. Every variable is static and final, and they are shared and unchangeable. Then we see void fly and void land methods. So every method declaration in an interface automatically is public and abstract. The compiler adds those modifiers silently. So fly means public abstract void fly, a method with no body and that implementing classes must provide. So this has a direct consequence for implementing classes. When you implement an interface method, you must declare it as public. The interface says the method is public. You cannot make an override more restrictive. Okay, so you cannot make an override more restrictive. Writing a protected void fly or package private void fly, basically default in the implementing class, is a compile time error. Now if you see the method default void hover, right, and system out.println hovering, so Java 8 introduced default methods also. So interface methods with a full implementation body, so marked with a default keyword. Implementing classes inherit this method automatically without overriding it. So if a class wants a different behavior, it can override it, but it is not required to. Default methods exist so that interfaces can evolve over time, and adding new methods without breaking every existing implementing class. Before Java 8, adding any method to an interface would break all existing implementations. Okay, and then we have static methods, right? So we have a static void info system out.println flyable interface, right? So Java 8 also allows static methods in interfaces. These belong to the interface itself, not to any implementing class or object. And how do you implement that? So we have class plain implements flyable, public void fly, public void land. And so plain here, it implements both abstract methods. Both are declared public, mandatory because the interface declared them as public abstract. Plain inherits over from the default method without doing anything. Plain does not inherit info, okay? And we'll see why in a moment. So static methods are not inherited, okay? So we see flyable.info, that's okay, but plain.info will lead to a compile time error. So interface static methods are not inherited by implementing classes. They belong to the interface and can only be called through the interface name, flyable info. So calling plain.info is a compile time error because plain never received info. Static methods do not transfer through the implementation. This is defined from static methods in class inheritance, where a static method can be called through a subclass reference. Interface static methods are stricter, interface name only. Okay. So three things to remember: that interface variables, they are always public, static, final. They are constants, never instance state. Implementing class methods must be public, cannot narrow the access, and interface static methods not inherited must call through the interface name only. Okay. So abstract versus interface side by side, right? So choosing between an abstract class and interface depends on the requirements of your design. The OCA exam often tests whether you understand the key difference between the two. The main distinction is that an abstract class can hold state. It can contain instance variables and constructors, allowing it to store and manage object data. An interface, on the other hand, cannot hold instance state. So any variables declared in an interface are constants, which are automatically public, static, and final, and are shared by all the users of the interface. Another important difference involves inheritance. A class can extend only one abstract class because Java allows single inheritance for classes. However, a class can implement multiple interfaces, which makes interfaces the primary way to achieve multiple inheritance type in Java. So there is also an important rule involving default methods. If a class implements two interfaces that both define a default method with the same signature, the class must override that method. Okay, so this is necessary, otherwise, because the compiler cannot decide which default implementation should be used. So inside the overriding method also, the class can optionally call a specific interface implementation using the syntax interface name .super.method. Okay. So if we see the code, we see class duck extends bird, implements flyable, swimmable. So a class can only extend one other class. Single inheritance for classes is a hard rule in Java. But a class can implement any number of interfaces. Duck extends bird, that's a one parent class, and implements both flyable and swimmable. The interfaces are listed after the implement keyword, separated by commas. This is how Java achieves multiple inheritance of type. Duck is a bird, a flyable, and a swimmable simultaneously. Any code that expects a flyable can receive a duck. Any code that expects a swimmable can also receive a duck. One class, multiple contracts, it will be satisfied. Okay, so we see the interface A default void hello system.out.println A, and interface B is default void hello system.out.println B, right? And class C implements A B and then public void hello a.super.hello. So here is where multiple interface implementation gets complicated. Both A and B define a default method called hello, same name, same signature, both with implementations. When C implements both, Java has a problem. If you call hello on a C object, which default should run, A's version or B's version, we have to understand that. So Java, it cannot decide. This is ambiguous. So Java's solution is to force the implementing class to resolve the conflict. So C must override hello. If it does not, it is a compile time error. By overriding hello, C will take the responsibility and provides a definitive implementation. Okay. Choosing which default to call. So we see a.super.hello, right? So inside C's override, you can optionally delegate to one of the interface defaults using the special syntax interface name.super.method name. Here C chooses to call A's default implementation. You could equally write b.super.hello to use B's version, or write completely new logic, and also could ignore both defaults. Okay, the choice is entirely yours. So once you have overridden the method, the point is that C must make an explicit decision. Java will not make it for you. Okay. So why this rule is there? So this is Java's solution to the diamond problem for interfaces. Before Java 8, interfaces had no default methods, so this conflict could never arise. So upcasting, downcasting, and class cast exception. So casting in Java means converting a reference from one type to another. The safety of a cast depends on the direction of the conversion. So upcasting converts a reference from child type to parent type. That is always safe, because a child object always satisfies everything defined by the parent class. So for example, a dog is always an animal, because this conversion is guaranteed to be valid. Upcasting happens automatically and you do not need to write an explicit cast. Downcasting moves in the opposite direction, from a parent type to a specific child type. This requires an explicit cast because the compiler cannot be certain that the object actually belongs to the target subclass. The compiler allows the cast but does not verify it fully. If the object at runtime is not compatible with the target type, Java will throw a class cast exception. For example, if a reference A actually refers to a dog object, casting it to cat will compile successfully, but it will fail at runtime because dog is not a cat. A safe practice when downcasting is to first use instance of operator. If instance of returns true, then the cast is guaranteed to succeed. The Java Virtual Machine or JVM performs this check internally during a cast, but using an instance of allows your program to avoid runtime exceptions and handle the situation safely. So we have to remember this. So if you see the code here, so upcasting is always safe and always implicit. Okay, so animal A is equal to new dog. Upcasting means moving from a child to a parent type. A dog is always an animal. Every dog satisfies everything animal promises. This is guaranteed by the inheritance relationship itself. So Java allows it implicitly. No cast syntax needed, no risk of failure. The reference type is animal, and the actual object is a dog. This is the foundation of polymorphism. However, downcasting, it requires explicit cast. If we see dog D, then within bracket dog and then A, right? So it's downcasting here, D dot bark. Downcasting goes in the opposite direction from a parent reference to a specific child type. Java, it cannot guarantee at compile time that the actual object really is a dog. Maybe it is a cat, maybe it is a plain animal. The compiler really doesn't know, right? So it requires you to write the cast explicitly, taking the responsibility yourself. Okay. So here the cast is saved because we know that A was created as a dog. So the cast succeeds and d.bark works fine. Okay. So if we see cat C and then cat casting of A reference, it will compile, but it will lead to class cast exception at runtime. This is a trap, right? So A holds a dog object. We try to cast it with a cat. So a dog is not a cat, completely unrelated types. The compiler does not verify whether the actual object is compatible, but it trusts you to know that you are doing what you are doing, right? So this will compile without any error or warning. At runtime, the JVM will check the actual object type. So it finds a dog, not a cat, and throws class cast exception immediately. So lesson is the successful compile does not mean a cast is correct. The danger with downcasting is entirely at runtime. So instance of before casting is a safe pattern. Like we see here, if A instance of dog, then dog safe, then dog casting A, and save.bark, right? So instance of checks whether the actual object is compatible with the target type. If it returns true, the cast is guaranteed to succeed. The JVM already verifies the type internally. If it returns false, you skip the cast entirely and avoid the exception. This is the correct pattern whenever you downcast. Always check the instance of first, then cast confidently inside if block. Okay, and instance of with interfaces, it always compiles. So you see here, if in A instance of flyable, when you use instance of with the interface type, it always compiles. Even if the compiler cannot prove the object could ever implement flyable, right? So the reason is that a subclass of animal could implement flyable somewhere in the hierarchy, and the compiler cannot rule that out. So the interface instance of checks are always permitted at compile time. So now we come to the practice question. So we have an interface printable, then abstract class document implements printable, class report extends document, and then we have public static void main, right? So what is the answer here? Answer is B, compile time error at A. So why is that so? So if we let's understand the structure first before we trace the code. So printable is an interface with one abstract method, print. Document is an abstract class that implements printable but does not provide a body for print. It leaves that obligation to the concrete subclasses. Document adds to its own concrete method save and an instance variable title. Report extends document and finally provides an implementation for print. Report is the first concrete class in the chain. Okay, so we see that printable P is equal to new report, and the reference type is printable. The actual object is a report, so that's valid. Report implements printable through its interface chain, so report is a printable upcasting to this interface type. So we see p.print. So compiler checks, does printable have a print method? Yes, it is the one abstract method of the interface. This call is allowed. At runtime also, the actual object is a report, and report has overridden print. So dynamic dispatch runs reports print, output is printing Q1. Okay. Then we have p.save, and the compiler again checks, does printable have a save method? No, printable only declares print. The compiler knows nothing about save when looking through the printable reference. Save exists in document and is inherited by report. The actual object at runtime has a save method, but the compiler does not look at the actual object. It only looks at the reference type. Reference type is printable, and printable has no save, so it will lead to compile time error on line A. Okay, so if you want to practice such questions more, so we have javalearn.clustermicro.com. There you will find 1624 practice questions, time exams, and 29 full-length practice tests are also available. It's a fully cloud native platform. You will get very detailed explanation. Thanks for your time.